Welcome all of you to the part 2 of week 7 code walkthrough sessions. In this session, we will, as promised, we will discuss about packages and followed by assertion and logging. So let's dive into the session. What are packages? If we ask this question, so basically, from the day one that we have been learning Java, you might have seen this package word written over the code editor that we have been working upon, right? Package Java 5 or package default, depending upon your IDE. If you are using the Eclipse IDE, there is package default package there. But anyway, so this package thing is written there. So what is it that we are seeing from day one, but we have not yet studied about it? So let me just go to the file explorer and show you guys something. What happened? Okay. So you see that this is my file explorer, and let me go to the src folder. So you see that there are Java 1, 2, Java 3, like till Java 7, we have these 7 folders, right? And if I go into each of these folders, you will find the .java class files, right? So all these .java class files. So essentially these are packages. Java 1, Java 2, Java 3 till Java 7, each of them are nothing but packages. So what are packages? Inside, I mean, when we discuss the rules, we will see there are multiple rules with respect to packages, but essentially they are simply folders or directories in which we have our Java.java files. Okay, so the Java files that we are writing, the code files, they are present inside these folders, and these folders are nothing but packages. So Java 1 is a package, Java 2 is a package, Java 7, Java 4, all of these are individual packages. Now I can also have these interleaved, or let's say multiple levels of packaging. So inside Java 4 I can again have another new folder. I'm not creating it now, but let us say we can have another new folder with some name, right? And inside that again we might have a few classes, I mean .java file. So some .java files are outside, so whatever Java files are over here, I will keep it as it is. Along with them again I have another new folder. Now inside that folder again I have a few .java files. Likewise we can have this hierarchy of files and folders, and these folders, or let's say directories, are basically the packages. Now that is from the file explorer point of view, or from realistic point of view. But when you go to the Java coding environment, right over here, then these packages, so basically if you are let's say this access modified demo.java, this particular class, not class, this particular file, it is defined in the package Java file. So every code that you are writing, every Java file, on top we have to mention under which package it is written, or under which package does it lie. So package Java 5, so Java 5 is the folder under which this particular program .java file is there. So if I would have opened the Java 5 folder, you could have seen access modified demo.java file would be there. Okay, so every Java program has this mentioned on top of it. Package under package Java 5, that means this code, this program, this .java file is basically present inside the Java 5 package. Okay, now that is fine. There are many security rules with respect to packages and why these packages are used. We will come to that. But let us know a few rules that are already there. We will discuss that, and then we will go to the in-depth analysis of what packages are and how they are used for security purposes. So the first thing is that you cannot have two same name classes within the same package. Why? Because a package, essentially you saw basically the reason for this is again actually related to this third point, okay, that only one public class in a program is allowed, and that must include the main method. And not only that, that .java file would be named on the basis of that class name. So there are three things. Every java.java file, the name of that .java file will be same as the public class name. And since there is only, I mean, one name, therefore always there should be only one public class in a .java file. And if there are, and if, I mean, if you are putting main method in a code, I mean, main method is not compulsory to be there in all of your .java files, right? Some yeah. So if you are defining a utility function, so in one of the Fibonacci.java, I think we are only using two methods were there. One is Fibonacci sum, and another method was some Fibonacci. Basically, we are basically calculating the Fibonacci numbers. So there, I am not using any main method because those are utility function, and some other programs will basically use those functions. So in such a situation, I do not have to write a main method in a code. But if you have a main method in the Java file, then it should compulsorily be inside that public class. So again repeating, there should be only one public class in a .java file. And a .java file would be named on the basis of that public class, not on the basis, what I mean is that name will be directly copy pasted. So that file name would be that public class name .java. Okay, and therefore there should be only one public class. And if you are putting your main method, then you will have to put your main method within that public class only. If you put your main method in any other class, right, then your main method would not be called. So the program will not run basically, because the entry point in Java programs is through the main method. Unlike Python, where you can actually iterate without the main method also, execute without the main method also. But in Java, you cannot do that. So you have to have the main method. If you are executing a program, not utility functions, but a complete program, then the entry to the program will be through main method, and that main method should compulsorily be present inside the only one public class in a .java file. Okay. Now, since this is a rule, this rule also transitively creates another requirement, that is, you cannot have multiple same named classes within a particular package. That is basically practically within a particular directory or folder. As we saw, packages are nothing but folders, right? So why this is so? Because since we now know that only one public class is allowed in a .java file, so assume that a particular package has two same named .java file. That would essentially mean you have two same named public classes within the same package, right? So that is something which is not allowed, and that is, I mean, problematic. You will, if you want to reference that particular class later at some point, you will not understand which one are you referring to. The Java compiler will not understand which particular, I mean, class we are talking about. It will get confused. So within a package, you cannot have similar named classes. Let's see a small brief demo of that. So let's say I have this Java 4, right? I can, in this Java 4, I can create a new file, new Java file, and let's create a class, and let me enter the class name as, see, in Java 4 we have code 8, code 9, 11 and 12. So I will use any one of the name. Let's say code 8 dot Java. Generally in ID we do not put, we simply write code 8. You see, class already exists, so it will not allow me to create a same class name, I mean same class .java file. Okay, so if I write something, if I let's say write code 67, then it is giving blue, and if I press enter, then the new class will be created. But if I write again let's say 11, then again it is same class already exists. Okay, so here inside the Java 4 package it is not allowing. But let's say I have this code 6.java inside Java 3 package, right? Java 3 package, I have this code 6.java. So now I am inside Java 4. So can I write code 6 over here? You see, this is allowed. So code 6, if I press enter, then it will allow me to create a code 6.java .class file, .java file. So you see that within package you cannot create same named classes, or let's say same named .java file. But outside of package or among packages, you can have similar named classes, because that's under a separate directory, so that is fine. That will not create us problem. And later on, if you have a let's say code 8.java inside, let's say, or let's say you have this code 6.java inside Java 4 package. Later on, if at some other part of the code, some other code, if I want to reference this Java 4's code 6, I can reference it by using the fully qualified name. Now, what do we mean by fully qualified name? We will discuss these points in detail, but just as mentioning it over here, since we are already on the topic. So if I want to use the code 6 class of Java 4 package and not Java 3 package, then what I will do is I will write Java 4.code6, import Java 4.code6. Whatever. Right? Like we have been importing many things, right? Now we will discuss what is that import statement in detail. So you can write import Java 4.code6, or if you want that Java 3's code 6 we want, so we will write import Java 3.code6. In fact, all the import statements that we have written till now, let's say in case of scanner, we wrote that java.util.scanner. So what are those so Java is a particular folder. Within that folder, util is another folder, subfolder. Now inside util subfolder, there will be many classes, and one of the classes will be the scanner class. So this is how it is. This is how it is arranged. So there, so we go, in order to mention the scanner class which is present inside the util subfolder of the Java folder, we will mention java.util.scanner. So then that class will be referenced or imported, right? So likewise here also we will do the same. So since we have discussed this part, now we will come to what are these packages, and so we have seen the basics thing, what packages basically mean. Now we will learn the rules about it. So first thing is, we know that every program will be inside one of the packages, and that is mentioned at the top by writing package, then the package name semicolon, right? And again, I might want to actually import the I told you in one of the previous sessions that what we want is, let's say a part of a code is there, and that code is in one program, and I want to access the utility provided by that code into some other program. I don't want to write that code again into another program, right? I have already written it as a part of one program, and there is another program which requires similar level of or similar kind of, let's say, functionality. So what I do is I can directly import the code written into that other program inside my current program and use it. So how to do that is by basically using this import statement, and we have been doing that. So in order to use that, we will write import, then package name, then let's say there are sub packages dot sub package name, whatever, dot. At the end of the day, we will write the dot class name, put semicolon. So then that class will be imported. So that's, we have already done similar kind of things. Let's remove this. You see that here this import Java 5 dot star. What are we doing over here? In this particular program, we are importing Java 5 packages inside Java 5 package, whatever classes are there. Dot star means all the classes inside Java 5 package. So all the classes inside Java 5 package will now be imported inside the Java 4 package, which is basically, I mean, that is not permanently imported. Don't think that it will be copy pasted inside Java 4. Only for the only in the scope of this program, the classes inside Java 5 will be temporarily be available inside, or let's say temporarily be accessible, not available, accessible inside the Java 4 package. Right? So, I mean, in this program. Now here I can use the Java 5 classes which I have defined inside the Java 5 package. All those classes can be used. I can create objects of the Java 5 classes. Now, another way to actually, without writing the import statement, so let's say what is there inside Java 5, we have this access modifier, this access modifier demo.java, right? So here I can, as you can see, I will come to the code in details, but just see as of now, the access modifier demo, we can create an object properly. Right? In line 28, we are creating an object of access modifier demo class, which is basically present inside this Java 5 package, but now we are currently inside Java 4 package, inside code8.java, this code8.java, Java 4 package. Inside this, we are importing this Java 5 packages class, and we are basically creating an object of that class. So it is available. See, there is no red mark. It is correct. But again, I can do it if I remove this, right? If I remove this or comment this out, then it will give me error, obviously. So if I go down now, this see access modifier demo is showing me error. I mean, because it is not recognizing what is it. So in order to make it recognize, I can have another way to do that, and that is, if I only need one class to be accessible, right? I do not need all the classes which are present inside the package. Then what I can do is, rather, I will mention the fully qualified name. So these are two techniques of accessing a part of a code written inside another package. Either you import the package completely, or you mention the fully qualified name where you are accessing that class. So this Java access modifier demo class is there inside Java 4 package. So I will write not Java 4, Java 5 package. So Java 5 dot access modifier demo, and then again new over here Java 5 dot. So see the error has gone now. So this is what we call the fully qualified name, accessing a particular class by using fully qualified name. Either of these two things are correct. Okay, so now let me just go back to the previous one only. No reason, you could have kept it as it is also, but here I have commented out, so I will uncomment it. So accessing packages, defining packages, right? If you want to define a package, I mean start a new package, so you have to create a new package in your directory, and then you have to, if you want to put programs under that folder or basically under that package, you have to mention that package name on top of the program, and then you can write whatever you want to write. Okay, so coming back to our main code. So that was about packages. So we have seen this 3 point. Packages can be accessed either by import or fully qualified name. I mean that we have seen same named classes are not allowed, and only one public class will be there inside a particular java.java file, and that would be the name of the file as well, and the main method if present should be present inside that class. So again you can check that over here. If I try to make this class public, see what will happen. Get an error, right? So 2 public classes are not allowed. Okay. So now we will go into the access rules. Now we just saw inside this other code, right, that if I want to access this access modifier demo, right, I can directly import it or use the fully qualified name and I can access it. Actually, it is a little bit more trickier than that. There are some rules for accessing classes or any other any other element defined inside one package, or let's say defined inside one particular program, being accessed in another package or being accessed in another program. So there are some rules. So we will see those rules. So what are those rules is, let me just briefly mention it over here. So first of all, there are 4 types of access modifier. So this is what we call in Java access modifier. So how much access is allowed to a program element? That element can be a function or a class. So what is program element? The program element that we are talking about is basically 2 things. The number 1 is classes, and number 2 is functions. Other than these 2 things, there is nothing else, right? So functions and classes. So how much accessibility scope will these 2 things have depends upon the access modifier. So the access modifiers defines the accessibility scope. For these 2 things. So that means each of these, that is classes and functions, both of them must have some associated access modifiers with them, right? Correct. So classes have 2 access modifiers associated with them. Number 1 is public. Number 2 is default. Now we call it default. Some books or some lectures you will see we call it package private. Anyways, the thing is same, and the most important thing is, in order to have the public modifier, we will have to explicitly mention the word public. That's what we have been doing, right? But default, we will not write default keyword in front of the class. Default, we call it default, so we must give it a name, right, to display to basically communicate the concept. We call it default access modifier, or many people also call it package private access modifier. But whatever we call it, we do not write any keyword like default or package private in front of the class name, right? So how do we get this default? If you do not write anything, just directly write class ABC whatever, then that is by this is why we call it default. Then that class will be by default in the default access modifier. Okay, then this is the reason we call it default modifier. So by default, if you do not write anything and simply define a class, that would be in the default access modifier. And if you want public class, then you have to write public, right? So this is one thing. But also classes can also be other than these 2, there are also 2 other access modifiers in Java which are private and protected. But classes, at least the top level classes, are not allowed to be declared as private or protected. What do you mean by top level classes? Top level classes means which are outer class, which are basically not nested inside another class. Right? So outer classes can only be public and default. But inner classes, so these are, let me write it in this manner, top level classes. Top level classes are only allowed to have public and default. But if I have inner classes can have, obviously public and default is anyways there. Other than that also we will have private, that we have already seen, right? So we have the iterator implemented using a private class, node implemented using a private class inside the linked list outer class, right? Private, and we can also have protected. But again, private and protected are not allowed to be written in front of outer classes. Outer classes can either be public or nothing. Nothing means default. Okay. So these are the modifiers. And functions, if I talk about functions, then functions, there is no concept of inner, outer or something like that. So function can have all the four modifiers associated with them. Now, as I told you that these modifiers basically define the access of each of this element, right? So we will see in the code how these accesses comes into play. Okay. So in this program, what we are doing over here is there is a class, public class. Now you can see there is a public class, and this is what default class. And now we know that. So public class access modifier demo, and in which we have 4 display methods. Now each of these display method has a different access type. So this public, private, protected, and since I have not mentioned anything, it is by default, it is a default modifier, right? The top one, display 1. Display 1 is default, display 2 is public, display 3 is private, and display 4 is protected. We have these 4 methods associated with them. Okay. I will come to the access modifier related with the classes a little later. Let us first discuss the access modifier related to the functions. Okay. Now, since I have these modifiers related to the function, they will define the access scope, as I have told, access scope of this function. Now, what are the rules for the access scope? See, public type. Let me again go back over here. So, when you have public, let me write. Right, if I have, if I have public modifier, this is accessible everywhere. Right, everywhere it is accessible. If I have, let's say, the other one, private, then accessible only within the class. Right, so whichever class the method is defined inside, only within that class this function can be accessible. Third one is, let's say, default. This is the reason we call default as package private also. This is only accessible inside the package. Anywhere but inside the package. Accessible only inside the package. So when I say only inside the package, what does it mean? So let's say there is a class, right? There is a package called Java 4. Inside that Java 4 package, you have multiple classes. So in one of the class, you have defined one method, right? A default method. Now that means that method can be accessed by, with proper, object declaration and all of that. That method can be accessed by any of the classes within that package, right? So within that package, as long as you are within that package, any class, any other class within that package can access this method. By defining an object and all of that, but basically it can access the method, default method, defined inside one class and accessed by another class where both the classes are, as long as both the classes are inside a common package. If you go outside the package, then default will not allow you to access, right? So Java 4, inside Java 4, if you have a class and inside that class there is a method, then that method cannot be accessed by any possibility or by any technique outside the Java 4 package. But that method can be accessed by any other class inside the Java 4 package. Okay, so that's why it is called package private. And the fourth one is protected. So what does protected do? It is accessible firstly within package. So within package is fine, or along with within the package, it at least provides a little bit relaxation, and it says, or you can access it outside package subclass. Outside package, but must be subclass. So inside Java 4 package, if I have a class named ABC, and inside that ABC class I have defined a method as protected, then in order to access that method outside the Java 4 package, let's say in Java 5 package inside another class I want to access this method, then I have to compulsorily define that class as a subclass of this class, right? So I will have to define that class as subclass of ABC class, and then inside that subclass I can access the protected method, right? So we will see all of these examples now in the code. So these are basically the rules, right? So first thing is, we will see, so this is the same Java program as we saw. Now we are inside the same program itself. Now let's say we have defined a new class, access modifier subclass. We have defined a new subclass which extends the access modifier. So let us see within the subclass. So what is this basically? This is subclass in same package. Now, so display one is what? Display one is default method, right? Or the package private method. So obviously it is accessible inside package, right? So this is inside the same package, so therefore display one is accessible. There is no red line. Display 2 is public anyway, so it is anywhere accessible. So display 2 is also accessible. Display 3 is private, only accessible inside that particular class, right? So it is accessible only access modifier class. So here I am defining another class, which even though it is a subclass, but still it is a different class. That's why display 3 is not accessible inside this class. Display 4 is protected. Now protected, as I told you, within the package protected is accessible, and outside the package inside subclass it is accessible. So this is within the package, within the same program only. So therefore display 4 is okay. Now we go to, this was a subclass, right? Subclass in the same package. Now we will go to this, which is outside, unrelated. It is not a subclass, it is an unrelated class in same package. So right. So here also within the, as long as you are within the same package, this subclass and non-subclass criteria will not become highlighted, will not be highlighted. Once you move out of the package, then you will see that protected methods are only allowed to be accessed inside subclasses. So because within the package anyways it is accessible. So display 1, which is of default type, it is anyway accessible, fine, right? Display 2, what is this code 8 error? Public type code demo must be defined in its own file. Okay, so we have defined this as public, yeah. Same reason as you saw earlier. So yeah, display 1 is default, so within the same package accessible. Display 2 is public, accessible. Display 3 is private, not allowed. Display 4 is what? Protected, but within the same package you are there, so therefore it is accessible. So you see these two are therefore showing error because private methods are not allowed to be accessed outside that class itself. So this is okay. Now what we will do is we will import this code, these methods into another program which is inside another package, and we will see what happens. And that will be code8.java. Code8.java is basically inside which package? Java 4 package. So inside Java 4 package we have code8.java, in which we will import these methods and see the access level in that access specification in that program. Okay, so that way we will be checking for outside the package accessibility. Okay, so being said that, once we are, before moving into the outside the package accessibility of function, we will dive back to a previous topic, which is basically access modifiers for classes, right? So that we have not yet discussed, access modifier of classes. So access modifier of classes is also same, public, private and protected work just like function, right? So whatever rule you have applied for functions, private and functions protected, same thing will happen. But there is a little bit difference between the public and default access modifier of classes. See, the thing is not difference, basically the idea is same. The thing is, if you are having a class which is default type, so basically you have defined the class as class something name, right? So that class is again, by default it is default type, and that's why it is package private. So that means you cannot access that class outside the package. That means, as I told you, there are two ways to import packages, right? Either you write an import statement or you mention the fully qualified name of the class with the package name and all of the stuff. Now, if you have a default class which you are trying to access within another package, then that is not allowed. So you cannot import any default class from another package, or you cannot write fully qualified name of any default class from another package. Likewise, you cannot do it for private also, but private classes are mostly inner classes. So since we are most of the time deal with the outer classes only, so I will talk about default and public type only. Okay, so if you have defined a particular class as default type in any particular package, then that class is not accessible outside that package. You cannot import it, you cannot mention the qualified name, fully qualified name to access it. So what is the rule? The rule is, if you want to have a functionality that you want to be accessed, or that you want to use in some other part of the code, then you have to define that class as public. Okay, only then you can write import statement and import that class and use the methods within that class, or only then you can have this fully qualified name expansion and work with it, right? So this is very important. So that's why if I go to the code editor, you see that this is access modifier demo class is public. If this would not have been public, I would not have been able to access it from outside the package. Okay, even if I write an import statement, it will give compilation error. Fine. So now let's go to code editor.java. As we already told you, so if you want to see the effect of protected access modifier, we will have to do a subclass outside the package. So this is a different package. As you can see, this is Java 4 package, right? Inside Java 4 package, we are having this another subclass extends the access modifier demo class. So access modifier demo was the main class inside Java 5 package, and inside the Java 5 package, we are basically importing this class access modifier demo and creating a subclass extends, right? So this is the subclass part. Okay. What else? This is the normal code 8 main method, and inside it we will see. So let us first take the main method part. Okay, so inside the main method, we have, what we are doing is we are creating an object of the access modifier demo class. It is a public class, so we can create an object, and also we are creating an object of the subclass that we have defined in this code. Both objects are created. So now I am using the object of the access modifier demo class to access the functions, right? So display1 function is not allowed. What was display1 function? It was default type, right? Why? We have declared it default type in the access modifier demo class. So now since it is default type, it is what? It is not accessible outside the package. You see, here it is not accessible. In the previous code, it was accessible, right? In the main method. So if you come over here, it was accessible. But here it is not accessible because now you have moved out of the package, and that's why even though you import it and do other stuff, it is not accessible. So importing is not allowing you to access it. Importing is only if the class is public, then you can import it. But again, the rules of accessing the function will remain same. Whatever the access modifiers are allowing you, only then you can be using them according to those rules, right? So object.display1, this is illegal because display1 was default type, therefore it is only accessible within the package. Outside the package, it is not accessible. Okay, display2 was, I think, public, right? Obviously. So display2 is accessible, public is accessible everywhere. Now display3 was what? Display3 was private, not accessible, obviously. And display4 was what? Protected. Now since this is outside the package and this is not inside a subclass, therefore display4 is not allowed. Right? It is showing error. Again, we are trying to access display4 by creating the subclass object, but still it is not allowed. Okay, now let us go to the subclass now. Now this will be interesting. So display1 is the default type, same reason, since whatever it is, subclass, superclass, unrelated class, whatever it is, outside the package means default will not work. So display1 will not work because it is outside the package due to the same reason. Display2 is public, therefore it is accessible. Display3 was private, not accessible. Display4 was protected. Now you see, although we are outside the package, still display4 is working here because another subclass is basically a subclass of access modifier demo class, right? Otherwise this would not have worked. So like in the main method, display4 was coming as erroneous, right? But here it is coming perfectly fine, right? Because it is a subclass. Okay, so now what we are doing now over here is we have this public access modifier demo. We are creating two objects, right? One is the subclass object and one is the superclass object. Now, and then we are defining a method inside this subclass, and then again we are trying to access those same functions using objects that we have defined. So let us see what happens. We are using objects to define those methods. Although the scope is inside the subclass only, the scope is same. Whatever scope this had or same scope these are having, but let us access it using object. So when I'm writing this display1, this basically means this dot display, right? So this is what's been happening, right? All of them are nothing but this dot, right? Likewise. So here I am using a user defined object O. So what is happening? O.display1 not allowed because outside package. Display2 public allowed. Display3 private not allowed. Display4. Now this display4 is not working here. Here it was working, but here it is not working. Why? This is something which is again a little bit tricky. So I told you that the protected methods are accessible within the subclass, even if it is outside the package. So if this is within the subclass, yeah. Is this outside the package? Yeah. So then this should be allowed, right? I mean, it is outside the package, but it is within the subclass. So therefore, display4 should be allowed to be accessed. So this is one rule over here. You see that if you have, within the subclass that you have defined of the protected member function, in order to access the protected member function, that protected member function can only be accessible within the subclass by the object of the subclass itself. Okay, so this is another rule with respect to protected access modifier. Although protected access modifier is allowing you to access itself from outside the package and restricting you to access it only within the subclass outside the package, but there is another additional criteria that while you are accessing it within the subclass, you must access it using instances of the subclass itself. You cannot access it using instances of the superclass. So that means you can access it using the object of another subclass, but you cannot access it using object of access modifier demo. And that is why here this dot display was there, right? Essentially, this is this dot display. Now, this is what this means. In this case, this is another subclass object, right? It's another subclass object. So therefore, this dot display is perfectly working. Here, obj2 dot display is perfectly working because obj2 is again object of the subclass. But o dot display, the parent dot display, is not working, right? Because of the rule of protected modifier that if you are accessing the protected method inside the subclass, then it should be accessed by instances of the subclass only and not the superclass instances. So basically, we have understood all the rules of accesses and all these things, right? So now let us. By the way, let me just tell one thing briefly. So, if protected methods, what is this protected access modifier doing? It is restricting the use of a particular method outside a subclass of a particular class, right? So basically, I cannot use this display4 method inside the main method or call it display4 method inside the main method or somewhere else, right? So if I am not able to call this method, what is the meaning of having an access modifier and inheriting it and all of that? You see that this protected access modifier, by taking the help of inheritance, it is restricting the usage of a particular protected marked method outside that class, but it is allowing you to use it inside the class. So these kind of methods are very predominantly used as factory methods. So what are factory methods? So let's say not this kind of method. Basically, what we can do is with protected. Sorry, I said something wrong. Just rewind it. So what I mean is, let's say you want to have a functionality that you have a class which is very critical and you do not want anyone to create object of this class. You want to check condition, you want to ask questions, and then only you are allowing the user to create an object of the class. So simply by typing new, you don't want to allow the object of that class, because having an object of that class means you can do some critical stuff, right? So in order to not allow any user to just write new critical class and get an object of that class, what we can do is we can define the constructor as protected. So if you define the constructor as protected, then what will happen? So any subclass only can access it. Outside the subclass, it will not be accessible. Got the point? So in that kind of situation, you can have other methods do an initial check on whether you want to allow the request to gain an object or not. If so, then only internally, because the internal methods now can access the protected method, it can call the constructor and allow and return you an object. Right? So those functions are called factory function, and this is one application of protected. You might say on similar lines. Anyway, so we have seen the rules, all the rules of these packages and how we access them and how they are beneficial, right? Okay, so now we will go to the next topic, which is assertions. Now, what are assertions? See, the assertion is nothing but it is a tool that is mostly used. So I have taken this lines of code from this core Java fundamentals by Horstman Prentice publication, right? So what is it saying? That assertion checks are turned on only during development and testing. So what are assertion? English word assert means that I am forcing, not forcing, I am asserting means I am asking that check that is this happening or not. It is kind of forcing, but not in that, let's say not in that much raw sense. So I am asserting means I am saying that, okay, that check for this, or I am expecting this to happen, something like that. Okay, so let's say I write assert in this example, code 9. What we are doing over here is we have this Java 5.Fibonacci function, Fibonacci class. So we are creating an object of that class, and what I'm doing over here is that Fibonacci class has some method fibsum, which basically calculates the summation of first I Fibonacci numbers, whatever I value I return. So it will calculate the summation of the first I Fibonacci numbers. Correct. So this is some code, and now what I'm doing is I'm calling f.fibsum. F is basically the object of Fibonacci class. Okay, now let us go to this Fibonacci class and see what's happening over here. So you see that this fibsum is the method. Now inside here I write an assert statement. Assert is not doing anything new. What it is saying is if I is greater than equal to 1, right? So the argument given, if that is the case, then argument given to this method must be greater. If that is not the case, then the argument given to this method must be greater than 1. It should happen, right? So I'm asserting this value to be greater than equal to 1. But if that does not happen, then argument given to this method must be greater than 1. It must be greater than 1, and the entered value that you have given is, we are printing the entered value, right? So that I do not have any negative number as a part of the first minus 5 Fibonacci number summation. That doesn't make sense. So I want this to be asserted over here. That means I want, before calling the fibsum or fibn method, I want to check whether this condition is holding or not. So I'm asserting the I to be greater than 1. If that is not so, then you print this thing or do this thing. And so this is assert. Now why it is used in debugging? So every time there, in a big program, in a big module, there are going to be multiple of function and multiple internal things which might be going on in a very cumbersome manner. So you write this multiple assert statement in different positions of the code, where you want to check for something or where you want to expect, right? Mostly I would say the expect, that you expect, let's say at this point this array will be half filled or something like that. So whatever it is, you can have multiple assert condition. Okay, so you expect this to happen. So that is what assert is. Now if that does not happen, it will launch a code, launch some response that you have configured into it, right? So if there is some trouble coming while integrating a particular software, a big software, right? So by looking at the assert statement, you will understand where there is the problem, where the error has occurred. Again, at the same time, you can say this can also be done through println statement. No, yeah, the println you can do, but then println you have to remove all the println manually or comment them manually in all the places that you put them. In order for assert, you can just turn off the assert by writing one simple command line command line command. You can turn off the assert, and therefore all the assert, none of the assert will be considered. So they will be just like commented out. So here explicitly you don't have to comment all the places. right? So this is another benefit. So now let us see, so assert is this much only. Now let us see how to basically see this assert in the action. Let me go to code 9. Let me open the terminal. As I told you that assertion can be started from the terminal. Okay. So since I will try to execute this code from the terminal, I will have to go to the proper directory. So I am currently inside Java codes and I need to go to src. So cd src, right? Yeah, bin. What I think src, obviously src. So I will go to cd src, right? So now I have all the packages over here. So I will be here only because I can access all the packages from this point. So I will write Java C, right? Just 1 second. So Java C, right? I will compile it. Okay. So since now I am at this level of the directory that packages are just, at the package level, I want to access, I want to compile a code means I have to give the package name, then I have to give the compilation class name. So Java code 9. Let's say Fibonacci, let's say combine this Fibonacci, compile this Fibonacci first. So Fibonacci is inside package 5, right? So Java 5 slash, okay. So that is compilation is done. And if you see in the file directory, you will get a .class file inside this package. You see that Fibonacci.class is generated. Now we will Java C, Java 4 slash code 8 dot Java, the main class file, right? Because we will be using this class file to call the main method and work upon the display defined in Fibonacci.java. Sorry, not display. What I mean is the ifsum defined in Fibonacci.java. So Java C, Java 4 code 8 dot Java. Oh, it should be code 9. Yeah, sorry. Code 9 dot Java. Right. So this is done. So both the dot class files are generated. Now I will execute it. So how to execute it? Java. Now here is the thing. If you want the assertions to show, right? This is the problem with print statement. You have to delete or uncomment as I told. Comment as I told you. But here, if I do not write anything, then everything will work normally. But if I want the assertions to be working in action, then I will mention that enable assertions, and then I will mention the class name of under which the assertion is given. So that is basically your Fibonacci class name, right? So that is Java 5, right? Java 5 dot slash Fibonacci Java 4. So I want to enable the assertion in Java 5 slash Fibonacci class, and I am executing. So Java will execute the code, right? So which main method code will it execute? Which is there in Java 4 slash code 9. So you see the sum of first 3 Fibonacci number is 2. It is getting printed. So that is correct. But that means this assert condition was holding. It is okay, right? So my I value was greater than 1. And if I go to the code 9, we see the I was 3. So since I was greater than equal to 1, therefore no assertions were printed. But now if I modify this as value from 3 to something else, let's say minus 9. Okay. Now since I have made a change to the code, I will have to recompile it. So I have recompiled it. Right. Now if I execute the, now you see exception in thread main java.lang assertion error argument given to this method must be greater than 1. Entered value is 9. So you see if I go to the assertion now, argument given to this method must be greater than 1. Entered value is this I value, which is 9, minus 9. So this is an assertion error is generated. Right. So you can actually figure it out. If you have a complex, multiple modules, multiple system software, then if you are getting confused that our error is coming, but from which particular module is it coming? Sometimes these are simple code, but when you are basically having multiple different modules and complex software, then each of these modules is interacting and is sending and receiving information from one part to another among them. Then the error exception will look like, from which point it has started, you will not understand. So in order to do this debugging, what we do is we have these assert statements where we say that, okay, at this point I am expecting the value of this variable to be greater than this, or let's say some whatever assert condition you want to put. And once that is those expectations, if at some point that expectation is not met, that condition is failed, then you will get a clear idea that this is the point where this trouble is happening, right? So therefore it is a debugging tool mostly. Now the last thing for this week is logging. So logging, there are multiple use cases for logging, users for logging. The first is security purpose, that if you have a multi-user system and many people are writing code, first of all, if you want to do something that you can have a track of. So let me just state this example. Let's say you have made a particular package. In that package you have some classes and some methods defined, and you want to check later, let's say that package can be accessed by anyone else, right? All the other programmer in your company can also access that package and use the function defined by you. But now somehow you want to have a track of all the access request to that package, or basically whoever is importing that package, I want to, or let's say whoever is calling the particular function that you have defined, right, in that package, you want to have a track of that. So in such kind of situation, you can do logging. So what I mean is you can write a logger which will log in, which will be present inside that function body for which you want logging to be there. And whenever that function is called, that logger line will be executed, and a particular entry will be kept, or a particular entry will be logged inside. Now when I say logged inside, what I mean is logged. Now logged means where I can log. So these loggers are, Java loggers provide multiple places to log your entry. You can log it to the console itself, but then in our use case it wouldn't make many sense, because what I want is I am not there, some other person is using my package, so it should be, the entry should be put into some place where I can read it later and know it later. So maybe a file is a good choice, right? A password protected file. So inside that file I can write the entries. Got the point? So you can set a logger with the handler, and the handler. So again, we will not see logger in details, but what I mean is you can set multiple handlers with respect to loggers, and those logger will allow you to write any such event inside a file, or it can also send it on the web, or depending upon what kind of handler you are allocating to that logger, right? Or it can simply print to the console as well. So you can do that. So this is the basic idea of why we do logging, something like this. And there are multiple uses of loggers as well. So we'll see one simple example, and then we will stop this session. Okay. So let us go into the logger part. Okay. See, we have not yet learned about file handling. So if you would have learned about file handling, like in Python, what do? You basically write a open function, right? Open and then some abc.txt, and then you put it inside a file equal to open in bracket abc.txt. So this file variable is nothing but a handler to access that file, correct? So you use the read function, write function on this file handler. So in Java also you can have file handlers, but it is a little more complicated than simply writing open, and that's why we will do it in the next week. So how to do that? So once you have a file, you can access a file and write and reading into a file. So you can also put the handler of this logger as a file handler. So that's what I was saying. So in that case, all the entries that you want will be logged inside that file. Okay, fine. So by the way, let us now start. Therefore, let us add a logger in this method only. Let's say this is a particular Fibonacci class. Inside this we have these two methods, and I want to see whenever someone is using or this particular fibn method, right? Or let's say fibsum method if someone is calling or using, right? So I should get an idea of who is using that. And as of now, we are not allocating a file to it, a file handler. We will simply print on the console. But just know that with a very little 2-3 lines of code, you can do it to a file, and that file can be kept as a private permission file in Linux system. You can just add permissions, and then it can only be opened by you. Okay, so that's how you can make this kind of stuff. So how to make a logger? So let us have this uncommented at first. Okay, now I will define a logger. Let's say L1 equal to logger dot get global. Okay, so this get global, as discussed in the slides as well, this get global will return you a global logger. There is another method which is get logger, and get logger we have to pass a name. So any name, let's say my logger1 or my logger, any name of the logger. So these are the two loggers that I am defining. Now once we have defined the logger, that is not enough. We have to set the level. You know, in the lecture sir has taught us that each logger has levels associated with it. So now we will set the level of that logger, right? So if a particular level is set with respect to a given logger, any entry lesser than that will not be lesser than that means less in severity than that will not be printed to the console, or will not be printed to the file if you have handled the file with it, right? So let us go through it and we will understand. But where to do this set level thing? See, fibn and fibsum are two methods, and I don't want anything to do with this logger. This logger business. I want to have a logger entry whenever fibsum is used, but I don't want any task related to logger being done inside fibsum or fibn, because those are my utility function, and logger is something another let's say feature that I want to use. But object orientedly speaking, I do not have any relation between a logger and a fibsum method. So I don't want to do any task of logger, let's say setting the level or setting whatever, any those kind of task of logger inside any of these two methods. Right? So what to do? Where to do it? Maybe you can do it inside the constructor, right? Maybe a class, but then again, if you want to access only these two methods, fibn and fibsum, then we don't need. You can also have this as. So basically, what I mean is, if you have defined all those things inside a constructor, then each of these logger L1 and L2 will be different for every object. Now, logger is basically only one logger, right? Which will do something which is related to, which will not do something, which will basically log the necessary details which you want to log for that particular class. For every object, you do not set a logger. So having it for each object is not a good design as well, and that's why again we cannot do it inside constructor. So for any class method like fibn or fibsum, I don't want to do it because that is unrelated to the idea of object oriented programming, because I don't want to associate this utility method which is related to some Fibonacci or whatever calculation to a feature that I want to use logger, right? It should be independent. So that is one thing. Again, I cannot do it inside a constructor as well, because these loggers should not be there for each object basis, right? So it should be there for only the class. So now if I want to set the level of the logger or some other task I have to do regarding these loggers, where to do it? Not in constructor, not in member function. So one very good ideal position, ideal space for this kind of task is what we call the static initialization block. Now we have not learned static initialization block as a part of this course as of now, and but so don't confuse this idea with loggers. Okay, so static initialization block, we are using it in case of logger task, but that doesn't mean that static initialization block is mostly used with logger. No, static initialization block has a lot of other tasks. I mean, doing some bookkeeping tasks with the logger is also one good choice to be done inside a static initialization block. So what is the static initialization block all about? This is basically this thing. Okay, static and then curly braces. Now this, whatever I write within this static block will be executed even before you create an object of the class. So let's say you have this public class Fibonacci, but when I have not used this any of the method of the class, or I have not created any object of the class, then even the constructor was also not called. Forget about the method, the constructor were also not called, right? Because you have not created any object. But the static initialization block, whatever I write inside the static block, will be executed when the class is loaded. So whenever your Java internal is basically loading the Fibonacci class, going through the Fibonacci class into the memory, then only he will execute the static method. Right, so the static not method, static block. So this static initialization block is executed during the class loading time, right, by JVM, and therefore it is one of the first lines of first block of code that will be executed, even before the constructor, even before any other member function, right? So when the class is loaded, the static block will be loaded. Static block will be executed. So that's why this is a good choice for loggers, because I don't want it for a logger to be object basis, and also I don't want to mix the utility function with some logger task, right? And also, since I will not create object, I cannot do it inside constructor. Not create object, I don't want it to be associated with object. So since by the way, we do not want it to be associated with object, I can make this a static, right? So then it will be common for all the objects and classes property. Okay. And also, since I will not use this logger outside, I can say it as private. Okay. And also, you can keep it like this. But again, also, if you see the slide, another qualifier is added, not qualifier, another thing is added, which is final. Right? Final. So why? Because I will not change these loggers. I will just keep it as constant. So whatever I got inside it, we will keep it as it is. We are not changing anything. Right? So that's why in the slide you can see private, static, final logger, right? But the reason for that is like this. I am not using it outside class. So private, I will not change it. So final, and static, because we don't want it to be done in object oriented. I mean, for each object basis. Because if we have done it for each object basis, then I could have done my task which I'm talking about, that I will write inside static block. I could have done that inside the constructor itself. Right? So now let's come to the static block and complete our code. So we want to set the level of the logger. So L1 dot set level, and let's say I set the level to be. So you see these are the level. Level all means whatever you want to, I mean, any kind of logging you want to do, any level of severity you can do that. But let us say I set it for config. Okay, I set it for config. Yeah, and L2 I set it for let's say info. Right, and let's say this is not config. Let's say this is warning. So we have set the two loggers. Right, okay. Now, what I want to do over here is L1.info. So this is where we mention the importance of this. So I will write something over here, right? Inside this method, I will put a message prompt. So what is the level of this message? What is the level of severity of this message? Is it a info level severity? Is it a severe level severity? So I can change this to severe also. Right, or I can change this to warning or final or finest or whatever it is. So I can change it to any one of the severity level. So then accordingly that level of severity will be allocated to this particular message, right? And then we will see why it is important. We will see just now. So L1 dot this message is at info level. Let's say for L1 dot info message, and let's say fib sum is used. I don't have to write who used it because I don't know. Someone will use it at runtime, and that will be also recorded. No problem. So fib sum is used, and then L2 dot info. Or let's say L2 dot severe. Fib sum is used. Actually, let's keep it as info as well. Be easy to compare, right? Only one thing I will change. Let's say this is not info. Let's say this is fine. Okay. Now let us see what happens. Level is set. Okay, so essentially I have set the level to be warning in case of L1 and fine in case of L2. So if I have anything while logging, if I write a log which is more stricter, any string or any message which is more stricter than warning, so L1 will only print that. Anything which is less stricter than warning, it will not print that. L2 will accordingly print anything which is more stricter than fine, and anything lesser than fine, less stricter than fine, will not be printed. So as you can see over here, L2, both of them are info, printing it in an info level of severity. If sum is used. So let me just write it one thing. If sum is used, the source is L1, and here the source is L2. right? So both of them are printing at info level, but you see that info level is a higher severity level in relation to fine severity level. Relatively to fine level, info is a higher severity level. So L2 fine is for L2, so L2 will be printing this line, but L1 is already set to severity level of warning. So if you are writing an info message for L1, so that will not be printed in the console. Why? Because L1 severity is set to warning. So anything warning or more than warning will be printed, right? So if this is the case, now if I go to the Java C, Java 5/fibonacci.java, right? So this is compilation done. Java C, Java 4/code9.java. Right now we are not thinking about assertions and those things. So let us also correct it. So wait. So let us also make it as, otherwise it will not work, right? Assertion will. Okay. So since we have changed the code9 function, we have to again compile it. Right now we will execute Java. Let's say since I'm Java 4/code9. So now you see this July 5, 2025, 4:19 p.m. Java 5.fibsum. So this is the method that is being called. Info is stating, fibsum is used, right? And L2 is getting, L2 is the one who is telling that, right? So if I go to this Fibonacci, and by the way, this Fibonacci value is printed, summation of first 8 Fibonacci numbers. So you see that L2 is printing, but L1 is not printing as expected. But if I change this warning level to finest, right? Okay, then up to also. What happened? Finest. Finest and finite. So both of them should print. Let us see just a second. Yeah, anyways, it should print. I think some problem with ID is there. Give some time. So you see now it is working. Some issue was there. You see that both L1 and L2 now saying that info level, and yeah, so both of them are basically printing, right? So because we have now changed the severity level, and that's why it is working. Right? So this is basically Fibonacci, sorry, not Fibonacci, this is logging, where you basically take a logger, set a level with respect to it, and then now one benefit of this is you can also do it in debugging also. You can use it. Why? Because let's say you use a logger and then set wherever you find that these are the critical positions where error can occur, or these are the values that I want to check. You can put a logger dot, let's say, warning, like L1 dot warning, and then you can write a statement which will tell you what is the problem, or some information that you want to keep. L1 dot warning. So likewise, you can have different hierarchy of types of statement. So let's say I want to check whether these inside a particular method, a particular variable should have these kind of values, maybe even numbers only, right? So you can have that kind of check using you can put that kind of message over there using a logger at a level of, let's say, severe. Let's say this is very important, so you at a severe level you put, right? And then other place where not so important condition is there, you can keep that as, let's say, L1 dot fine, and then you can write the message, right? Now when you are basically trying to print it, right? So, or sorry, not print it. Basically, when you are executing the code, before executing the code, you can set the level accordingly. So if you don't want those lighter versions of information being shown or being checked, then you can just set the level to a more severe version, and that will keep, take care of this thing, and only the more severe versions will be, more severe messages will be printed, and the other ones will not be printed. Right. So likewise, basically this is the logger. You understood the thing. Now you can implement in multiple fashion. But primarily speaking, one very common example to share with you guys is the thing that I just did. That you can have a package in that you can have multiple methods, and you can actually track that whenever that particular method is being accessed, at what time on which day, right? That particular method that you have written is being accessed, right? So you can do that. And again, this has multiple other functions as well. There are many things with logger, but we will not go into that much detail. Briefly, we have seen, right? So yeah. So that's it for this session as well, because we have discussed assertion, logger, and as well as the packages. 3 quite different topics. Okay. Yeah, so thank you all. Hope this will be helpful for you guys, and we will meet you in week 8 code walkthrough session. Okay, thank you all.